Good morning, everybody, and welcome to today's Shure webinar. Today we're going to be discussing wireless for guitar players with System Support Engineer Dave Mendez. Before we get into the bulk of the presentation, just a few items of housekeeping. This webinar, as all our webinars, will be recorded, and you can always find all of those archived webinars at shure.com/training. So if you want to go back and review this or you want to point your colleagues to its direction, just send them to shure.com/training. Second of all, if you have any questions, please feel free to ask them. We will get to them at the end of the session. There's a little pane in your upper right-hand corner of your screen that will have a question pane. If you can't see it, just click on that orange arrow and that will sort of unminimize that little pane. So feel free to ask any questions, and like I said, we'll get to as many of those as we can at the end. So without further ado, I'm going to pass it off to Dave. Dave, tell us all about wireless for guitar players.
Thanks, Cheryl. Hello, everyone. So as Cheryl mentioned, we're going to be discussing how to use wireless systems for guitar, bass, instruments, that sort of thing, but mostly guitar players. And not just how to use it, but also I know a lot of you are probably out there wondering what to buy, especially approaching the holiday season, maybe looking for a new wireless system to use or to incorporate with your rig or to upgrade from the current system that you have. So some of the things we'll talk about will improve functionality and performance of the system, but also some of the things we're going to be discussing are going to help you with the buying decision of what to upgrade to or what to purchase, okay? So what we'll be going through first off is some basics about how wireless systems work. So radio wave basics, things that are good to know about the components of the system and transmission characteristics and just some things to be wary about and some sort of terms to understand. Then we'll look into selecting a wireless system / using a wireless system, really. Important factors, which things are of primary concern, which things might be of secondary concern. Understanding frequency coordination, that's a big thing that factors into using wireless systems for guitar. And then, of course, system features that would be useful to understand and can help with operation. And then we'll kind of wrap things up with some setup and operational tips regarding things like what to do with the antennas as far as what type, placement, things like that, and various accessories that can improve performance, some multi-channel system things, so whether you're using multiple guitars or one guitar through multiple channels or whatever, but we're going to go through some of that. And then should we have time at the end, we'll cover some of Shure's newer systems, particularly digital systems. If we don't have time, that can be something, if you want to know about that, certainly ask in the Q&A. We'll try to leave at least 5 minutes or so at the end for some question and answer, and everything's on the table. So functionality, tips and tricks, Shure specific stuff, non-Shure specific stuff, things like that. We'll be happy to address that at the end. So on to how wireless systems work, some basics. So real basic, this is just, let's go through an overview of what a wireless system is as far as its components. So first and foremost, obviously you have the leaping bass player, leaping guitar player through the air. Usually there's an instrument cable obviously coming out of that, going straight to an amp or an effect rack or pedal board. In this case, obviously we're replacing that somewhat with a shorter instrument cable that runs directly into a body pack transmitter of some kind. And that's going to send your signal to a receiver of some kind. There's going to be different form factors of receivers. We'll talk about the benefits of those different form factors and where you might use them later. The one we have pictured is a typical single-channel receiver that can sometimes live on top of the amp or by the pedal board, but it has fixed antennas, and that's what's going to be receiving your signal. That's the thing pictured above the pedal board. And you still need cables, even though it is wireless, obviously. So there's going to have to be a cable that runs into your pedal board or rack or amp, and then a instrument cable that runs back to your guitar amp setup. But the main thing we're trying to replace is the 25-odd foot of copper with a wireless link, which ends up costing money, but that's the price of freedom. So some other terms. You might hear this diversity wireless systems. It's usually all over spec sheets or feature sets. What this is, and it's becoming one of these things where you almost have no choice to buy a system that's diversity as far as guitar systems, because most of them are. But just so you're aware of what that means and why it's important to use two antennas, a diversity wireless system is one that employs two antennas for one receiver channel and has some sort of internal circuitry that chooses which antenna is the best source of the signal. The idea being that older systems that were non-diversity, or newer systems that are non-diversity, only employ one antenna and are only looking at the signal at one point in space, which is fine, except as you move around the room, the stage, there are going to be spots where the directly received signal and the reflected signal, because again, the signal from your body pack transmitter isn't shooting out like a laser. The signal is kind of radiating outward. So you're going to get some direct signal, and you're going to get some signal that bounces off ceilings, walls, floors, and back. And the direct signal and the reflected signal could, at certain points in space, be out of phase, and that would yield dropouts. So the benefit of diversity with the two antennas is that you're reducing the probability that you'll have a dropout on both antennas. So if there's a dropout on one side of the receiver, uh, it will switch over or look at antenna B, and that is likely to be better, or more likely to be a good source of the signal, and it will reduce the amount of dropouts you get from this thing, which is called multipath interference. It's not radio interference in terms of another signal, but it's this phasing issue of dropouts, and diversity helps with that, and that's why it's important to have a diversity system, and it's important to use both antennas in a system, and we'll talk about setting that up later. Another thing to consider is just the gain structure of your system, because a lot of people will call in and say, I'm getting distortion, clipping, no matter what I do with my amp or my receiver. And a lot of times this is because the transmitter is being crushed. Your guitar players and bass players in particular call in because there's a lot of guitars and basses out there that are active or have active pickups, which means hotter output. And so if you just grab the thing and take it out of the box and plug in an active guitar or bass, it's likely that the hot output of that instrument is going to clip the input stage of the transmitter, so that no matter what you do, you're going to have distortion out of the gate, which is why we put in things like input sensitivity control and pads. And it's important to use those. So if you are hearing distortion, one of the things to check is those settings. And typically with active guitars and basses, a lot of times that will be dialed down fairly low, or the pad will be engaged as a matter of a rule, as a matter of course. A lot of times it could be a 12 dB pad, 10 dB pad. Some of our systems, like the older PGX and the current SLX systems, have a 3-position sensitivity switch, and usually for active hot output things, the lowest setting is probably a good place to start with those. And even with non-active, it's a hotter signal than a typical lavalier or headset microphone. And those body packs are trying to pull, sometimes double or triple duty, because it's the same body pack that you're using for your guitar that you would use for a lavalier system or headset system for presenting. So they have to have a pretty wide range of input sensitivity for different applications. So for you guitar players, we're kind of on the lower end of things as far as avoiding clipping. Some systems, though, remove this complexity by adding an automatic gain ranging circuit. ULX Digital, for us, has this, where you don't really have an input gain control. The system has kind of 2 gain ranges that it can sense what it needs, and it uses that one, and you're all set. And then you adjust your system gain by looking at the meters on your receiver and the gain control on the receiver, and that's the appropriate way to do that. So it makes it a little easier to use. Even that system, though, does have a pad. So that would be one thing where you'd kind of pay attention. If you see something on the screen like transmitter overload, or you're getting clipping, that's one thing to look at is a pad first. And with ULX-D, even with that kind of a gain ranging circuit, you might need some sort of pad, which is usually built in. Now, as far as how to set your audio meters, a lot of people ask about this. It's kind of different somewhat depending on digital wireless and analog wireless. And we'll get into some of the differences and benefits, which is better, quote unquote, later. But we like to say with analog systems, you've got a bunch of LEDs there. You paid a lot of money for those LEDs. Light them up. You want good, strong input, good, strong signal going in with analog systems to give you a good signal-to-noise ratio. If you run those meters too weak, you're going to have to make that gain up somewhere else, and it could yield noisier performance. So don't worry about an analog wireless system. Some examples would be like the older PGX or ULX analog, UHFR, things of that nature. Good healthy signal in. Even if you see the red clip light occasionally go on, that's okay, because in a lot of those systems you've got still a good amount of headroom. I think it's something like 6 dB of headroom with the analog systems. Digital, on the other hand, it's you still want to light up some of the lights, but it's not as important to drive it super hard. In fact, you want to kind of avoid getting into that super hard, driving the meter super hard, because in the digital systems, a lot of times that red light means that the limiter is already engaged, and you may hear some compression artifact in that case. So, in the case of a digital wireless system like a ULX-D, which is pictured there, um, you might, if you're lighting up the 3 green LEDs and occasionally the amber, that's probably good enough. You can make that up fairly easily without increasing noise, and that's good. But something like a UHFR or ULX analog, you could probably deal with lighting those up a little more. And of course, overload indicators are useful for that, and some systems do have a transmitter overload. I tend to like using wireless sometimes for the purpose of actually driving system gain a little bit harder, but more for my pedals and amps. Sometimes that yields a good solid tone. Another common misconception or question, I should say, is that I'm looking for a system that goes a long range, or what is the range of my wireless system is a big question that we get. And this is kind of a loaded question. There really isn't a specific answer. We do have a nominal range listed in the spec sheet. Usually for a typical UHF system, it's about 300 feet line of sight with the standard antennas provided. You could get more if you use different antennas designed for longer range. Um, for wireless systems like 2.4 gigahertz or higher frequency type things, it might be less. But the range really has to do with environmental conditions. They affect range probably more than anything else, right? So if you're in the UHF range and you accidentally choose a frequency that overlaps with a on-air TV channel, and you're outdoors, your range could be hardly anything, 5, 10 feet, something like that. But if you're indoors on that same frequency, you might get more range, and that's because the building could help shield you from that TV signal, and so forth. Your range is reduced by improper antenna setup, choosing frequencies that are not compatible. All kinds of things can affect your range. And in some cases, you may not know, because again, if you're only using 50 feet of range, and even if you've done something wrong, you might be getting good 50 feet of range. But the instant you go to 75 feet or 100 feet, you start experiencing dropouts. So range is difficult to quantify, but it has a lot to do with your setup and environmental conditions. And that's in the UHF range. In ranges like 2.4 gigahertz, same kind of thing, in that if you are choosing a wireless system that's on top of a Wi-Fi channel that's in use, your range might be reduced and dropouts may be more frequent. But if you choose a clean frequency, your range is greater. So here's more of a visual example that might help. So for instance, on the left, your chosen frequency is a really good one, right? And it should be noted, as you move around a stage, that red line, which is representative of your frequency, your signal, your guitar signal, is bouncing around. It's not static. And it could be bouncing around as much as 20, 25 dB or so. So you can see that on the left, that's a good frequency choice, because even as I move around, that signal can bounce around and be well above the noise floor. And so I might get, good 100 to 150 feet at least, probably more, before I have any kind of issue. The one in the middle is a little bit worse. The noise floor is a little bit higher. It's like a weak TV signal. And I still might have reasonable range, but again, as I move further away, I'm getting closer to that noise floor. And then, of course, the one on the right is an example of being on a really strong TV signal or being in an area that has a very high noise floor. And you can see that's, I'm only about 15 dB or so above that. And so I could be getting dropouts 10, 15 feet away from my receiver. So that's a picture of what we were talking about. Another thing to be wary of is body attenuation. So we're using guitar packs, and for the most part, if you have the guitar pack on the sort of lower part of your guitar strap, It's going to be away from your body enough that it's probably okay. Some people, though, may strap the guitar pack up higher or try to wrap the antenna around or hide it or put it closer to the body. Just be wary that the body is going to do a really good job of attenuating signal, and not just yours, but also the crowd. So this is one of those things where if you have the pack too close to you, or you've positioned your receiver in such a way that as you move around, there's a lot of people between you and the transmitter, your guitar transmitter, that's going to cut down on reception and then therefore range. So you can see in that picture that if I move the receiver to the opposite end of where it's pictured, so on the side of where the pack is on the person's back, I'm getting good, solid, full signal. But as pictured, where the receiver is in front of me or that person, the signal has to go through the individual, and you can lose up to 15 or 20 dB of signal from body absorption. This is also, like I said, for if you're on a stage or on floor level and you've got your receiver on the ground, uh, it makes your range can be a little bit less as you go through the crowd. You benefit from the signal bouncing maybe off the ceiling and walls and things like that, but the direct signal is going to get severely attenuated by people. So just be cautious of that. Sometimes raising antennas or raising the receiver up onto the top of an amp or on a platform can help with that sort of thing. But body attenuation can be a big deal with wireless. Okay, so on to selecting a wireless microphone. What frequency range, what type of system, and this is just sort of some of the primary concerns here. Again, so let me skip that here and go on. Before choosing, some of you might have actually asked, can I still use my older wireless mics? Do I have to purchase something new? Uh, and we just stick this in as a warning because we have to keep hammering this home with regard to the 700 megahertz. 700 megahertz wireless you should have stopped using it June 2010. If you continue to use 700 megahertz wireless, uh, you may get caught. Technically, it's illegal to use. Uh, as an individual, it's less likely. Usually, organizations, churches, things like that might be more uh, noticeable, but still, it's likely that you'll get, even if you don't get caught, you may get interference from other services because 4G LTE and some other data services are now up there and using this spectrum, and it's only going to get more used. But a warning, if you are looking to purchase wireless on a budget, no one should be selling this frequency range either. So if you're looking to pick something up on the cheap on eBay or Craigslist, be wary. Make sure you understand exactly what the frequency range that the system tunes to, and that it's not 700 megahertz because they shouldn't be selling it. You shouldn't be buying it or using it. With regard to if it's a VHF system, which is much lower in frequency, these are typically older and fixed frequency wireless. These are actually completely fine and legal to use, and in a lot of cases, a good choice. Even though you can't generally tune them to a new frequency in case you get interference. Uh, there's not a lot of TV down there anymore, and this is kind of a range of spectrum that's out of the discussion with regard to future data services and white space devices and things like that. There just aren't a whole lot of VHF systems out there, but if you find one, it may work just fine. If you currently have it, it probably works just great. So just some more facts because these are common misconceptions about people looking to get UHF wireless. Microphones that operate below 698 megahertz, so between 470 megahertz and 698 megahertz, are still very legal, and it's a great choice of spectrum to use. And again, the 698 to 806 megahertz range, which is referred to as the 700 megahertz band, that must be replaced immediately. You don't need a license to run UHF wireless. That's a requirement that was removed along with that 700 megahertz auction. And you may have heard rumors that FCC is looking at voluntary auctions of broadcast spectrum. It is true. They do have approval to conduct an auction. It's looking like the most likely spectrum is probably somewhere in the 600 megahertz range, but we don't know how much of that is going to go, and we don't know when, because a lot of it has to do with that part in quotes, which is the voluntary part of the auction. Need to figure out how many broadcasters want to participate in this auction, are willing to be relocated into different parts of the spectrum. They need to figure out how much this is going to cost as far as who's going to bid for what spectrum and how much they're willing to pay, and then figure out repacking of TV stations to be able to conduct this sort of thing again. And it's going to be complex, and a delay was recently announced from, I think, by the end of 2014 to by the end of 2015 or something of that nature. So already a delay has been announced. This is something that is may happen, but it's still a while away. So don't feel like this is something that's going to happen like tomorrow or still middle of next year. This is a complex issue, and UHF is still very much usable spectrum. So how to choose the right wireless? Some primary things that you need to know. What are you doing? And by the fact that you signed into this webinar, we have a pretty good idea that you're a guitar player or bass player. But part of that application thing is not necessarily what are you doing, but how are you planning on doing it? And this can come into the whole, form factor of things with regard to receivers and, what type of system do you need, because different systems are going to have different form factors. But even more important, we're kind of going in order here somewhat. Where are you going to use the wireless? And is it one spot, or are you touring around? And this is important because of sources of interference, right? Mainly, what is the TV landscape in the various places you're going to be using wireless? Because it is different from city to city. So this is going to let you know which frequency band is the best choice, or potentially whether you need to buy multiple frequency bands to accommodate your tour. How many systems are required? And not just the ones that you're purchasing now, but are you already using wireless? Other UHF microphones in your monitors, intercoms, things like that. What else is in existence? And not just what are you using, do you know at the venues you're going to go to, what else is in use? And not just UHF. Again, if you're considering a 2.4 gigahertz wireless system or in another frequency range, there are other sources of interference in other ranges. For instance, 2.4 obviously has Wi-Fi, Bluetooth, some wireless video, other things like that. And so it's important to know to choose the right wireless. If you're going to be playing a lot of places that have heavy Wi-Fi use, really congested 2.4 gigahertz, that may not be the most appropriate spectrum for you if it's going to be constantly bombarded with interference. UHF may be a better choice. If you're a small group, not a ton of wireless, 2.4 is moderately busy but usable. 2.4 might be a better choice than UHF, especially if you don't want to be worried about this whole, worrying about different cities and what TV channels to avoid and things like that. So these are some of the important things to consider. We talked about TV, what to avoid. This is a picture of a scan of 24 megahertz or 4 TV channels wide. And this would be an example of a frequency band that would maybe not be a good choice for a system that tunes this width. I believe this was for an SLX wireless purchase. And I think this was Seattle. In this case, the person needed to do 6 or 8 frequencies, and this is not possible with a scan like this, right? There's too much TV. And which TV stations do you have to worry about? Well, if you have a scanner that produced the image below, whichever ones the scan tells you. But there are some online resources, and you can certainly call Shure product tech support or system support to assist with this. But generally, if it's a TV station that's of fair power, we're talking 300 kilowatts plus or something like that. Outdoors, 50 or 60 miles away, you're still going to have to worry about it. Or if you're indoors, maybe considering TV channels that are about 30 or 40 miles away, because again, the building helps shield you from that. Doesn't matter if it's analog TV that's somehow left over from the DTV switch. There are still some analog TV stations out there, which unfortunately they should have been gone away, but they're still there. Whether it's analog or DTV, same effect. You don't want to be there because it yields more dropouts, reduced range. Now, as far as 2.4 gigahertz goes, this is not bad spectrum, certainly. It is challenging because there's a lot of sources of interference that are not predictable. It's an unlicensed spectrum. And some of the times these things are not always on. Like TV channels are bad to be tuned to in the UHF range, but they're predictable, right? They're always there. You're going to find them no matter what. Wi-Fi can sometimes throttle up, throttle down. Other things can be bursting. The reason why it's important to have a scanning tool, but even scans can sometimes not catch bursting channels. So again, a system with a scanner is better. A system with a scanner and a backlink channel that will change both your transmitter and receiver at the same time, even better than that. Because then if you get into a situation where you start hearing interference with your 2.4 system, a simple press of the scanning button will not only find a clear channel in your receiver, or not a clear channel, but a clear set of frequencies within 2.4, um, but it will then reprogram your transmitter remotely. So you might be muted for a couple seconds while that figures itself out, but then you'll be back on with clean audio. So just as a summary, which frequency range should I choose? Well, UHF is still the largest available frequency range. And we typically have a number of frequency band options. That's the whole thing of knowing what city you're in, so you can choose the best frequency band within UHF to avoid TV channels and get you the channel count you need. It's predictable interference and really the least amount of competition from unknown devices today. Obviously, that could change with the whole white space issue. The other frequency ranges listed, 902 to 928 and 2.4 gigahertz, are free from any DTV signals or potential white space interference in the future, but they're not free from interference, contrary to some claims in the past. Um, they have other sources of interference, which are unlicensed devices and not necessarily predictable, and we mentioned some of those earlier. The 902 to 928 band is a different range that does still have consumer devices in it, some cordless phones, some RFID, things that are used by stores, some other types of systems, maybe security systems and things like that. So just be wary, know the environment you're going to be using the wireless in, and that can help you choose which frequency range is going to be appropriate. It should also be noted that as you go from UHF all the way to 2.4 gigahertz, you're going up in frequency, which means shorter wavelengths. And the higher you go in frequency, the worse the propagation is going to be. So VHF was actually the best as far as long-range propagation and through objects. UHF still pretty good. 902 to 928, a little bit worse. And 2.4 gigahertz is going to be the worst in terms of just range and body absorption, right? So good line of sight, it's great. You can get 100, 150 feet of range with 2.4 gigahertz, but you start factoring into account body absorption and obstacles and things like that, that's going to drastically reduce your range. And but a system like 2.4 gigahertz may actually do better indoors than outdoors uh, versus UHF, right? Because 2.4 gigahertz is going to benefit from inside reflections. The signal is going to reflect back to the receiver. Outdoors, there's nothing to reflect the signal back, so reduced range. So some things to compare these different ranges and which one might be better. The answer is it depends, again, on what you're doing and how you're trying to do it. So this is kind of the frequency coordination part of things. So worrying about outside interference is one thing, and coordinating around that. Worrying about system-to-system interference is another thing. So we'll talk about, how do you choose the second frequency, how do you worry about adding additional frequencies beyond that. So when you're trying to add the first frequency, again, that's mainly where you're trying to worry about avoiding known sources of interference, or maybe something that's not known, but it's outside of the system. And that's where the frequency scanning comes into play. So when you're setting up your first system, you can run a scan that should avoid any interference sources that the receiver sees. And there's two types of scans generally programmed into a lot of these systems. There's a channel scan, at least this is how we refer to things. And this is a channel scan that will search only within a group of compatible frequencies. So a lot of times manufacturers will program within each group or user group or whatever, there's a selection of frequencies that are compatible. They've been calculated to be compatible. The channel scan searches only within that group to find you the next good or best frequency within that group for your one system, and usually requires no interpretation by you. There might be an RF meter, you can look at that, but usually the receiver is going to find you a clear channel. The question is, where do I put the second frequency? How do I do that? So to add another one, an additional wireless, without the use of a computer, just using the scan feature, make sure that you've activated all other wireless potential sources of interference so the scanning can see it. So you scan for, we already talked about the first one, so this would be scanning for your second clear frequency. Turn on the transmitter for that receiver and match it to that receiver, either manually or using an infrared sync that a lot of times the systems will have. Some systems may have a backlink that automatically does this, but just know how your system links up. And then you can repeat this process, but make sure that you leave on the transmitters as you go so that the receivers can see uh, those and avoid them. If you turn transmitters off every time you do a scan, you could end up with 4, 5 receivers all tuned to the same frequency because they think it's clean. What that's doing, or if you're manually choosing another frequency to add in, you're putting the second frequency a certain distance away from the first one, and this is a function of the receiver specifications, their selectivity, the filtering, and the better the wireless system, the closer you can pack frequencies, and thus the more channels you can do. So it's pretty much one of the primary things you pay for in a wireless mic system, especially in UHF, is how many systems can I do? How closely can I pack these channels? So it ends up being kind of the catch-22. The more frequencies, the more systems you want to run simultaneously, the more you end up spending per system. And that's a function of the complexity and the robustness of the RF circuitry. So a really good UHF system, you might be able to space 400 kilohertz apart from each other, and then an entry-level wireless type system might be as much as a meg and a half apart. When adding more systems, you have to worry about sort of these harmonics that are generated by interactions between the systems. We call this intermodulation. So if you take these two frequencies, 190 and 195, you would expect just to see those two signals if you were looking on a scope or just whatever. However, that's not the case. Those two systems will interact with each other and generate additional spurs, harmonics, intermods, we call them, at evenly spaced away. So the spacing between those channels is 5 megahertz, so you'll see 185 and 200, and that's real interference. That can actually interfere. If you put a third system on those frequencies, you will get crosstalk, if you will, but interference. So the question is, the third system has to go and avoid all 4 of those frequencies, or be a certain spacing apart, and avoid, obviously, TV and the like. So you put the third one maybe at 203, but now you're generating additional intermod with the interaction of all 3 of those things. So this is something that's going to get fairly complex pretty soon, and it's the reason why we do the group channel scheme for users of one type of system. And it's also the reason that we have computer programs that assist with calculation, and the reason people call us and ask for frequency coordination assistance, because it is a complex thing. There's a lot of math involved, and we try to remove that complexity with some of the tools that we offer. So again, we mentioned the group channel scheme. If you are just using the same make, model, and frequency band in a UHF wireless system, you can do all systems in the same group. And that's key. We get a lot of calls from people that have mixed groups up. That's not generally a good idea because you don't know, say group 3 channel 1 could actually be the same exact frequency as group 2 channel 3, and you don't know that. These are independent calculations of frequencies that are done to give you different options, but there's no guarantee that things aren't duplicated. So again, all the receivers should be in the same group and different channels to be compatible, but this is only, again, only if this is the same make, model, and frequency band of system. If you've got a mishmash of stuff, this falls apart. You can break the group channel scheme if and only if this is being provided by a Shure engineer that has done frequency compatibility, or you've run a compatibility program and it yields those results, right? So if a computer program like our Wireless Workbench 6 or one of us has calculated a set of frequencies, and we give them to you in the group channel format, and it's all over the map, and you go, hey, I thought you said it had to be the same group and channel. True, but if the program calculates those frequencies to be compatible, that's fine. We're just warning you about if you're not using a computer program and you're just using the same make and model of stuff, you want to try to stick in that same group and channel scheme. The software is a great idea. If you haven't tried it, it's free, so what have you got to lose? You just have Wireless Workbench 6.0 is the latest one, and you can hop on to the Wireless Workbench 6 forum. There are links to the forum through the Shure downloads section under support, and also if you do a simple Google search for Wireless Workbench 6 forum, it should be one of the first things that comes up. You just have to set up an account, and then you can download Mac or Windows versions of that. So a question that came up actually yesterday, so I added this in, is multi-guitar system usage. So a lot of us are doing, we're not just playing the one telly, although I try to do that as much as I can. A lot of us want to have different guitars, maybe it's different tunings, or just in case there's a broken string. And so this happens a lot. Single pack is fine. A lot of people do this. Problem is it's hard to switch guitars, right? Because then you have to take the pack off and put it on the new guitar, and it can be kind of messy as far as song transition. But if you're on a budget, it might be necessary. But the question is multiple packs. It's not always possible. One, budget. Again, so these systems, even some of the least expensive wireless systems, are $300 or $400 a piece to replace that $12 guitar cable. So again, you may not be able to afford it. It's fine. If you can, even if you can afford it, sometimes the functionality of the system doesn't allow it. And I'm more referring to some digital wireless systems. We have a GLX-D guitar system that it should allow for 2 packs to be linked to the same receiver. Again, because it's a unique way that this operates, but no more than that. I think that's the limit of that, is to do 2. And generally, you're probably going to only have one transmitter linked to that receiver because there's some backlink communication going on with that system. But most of them, especially UHF wireless, you can do multiple packs, but you have to be careful about how you do it. If you want to do single receiver on an amp, you can do multiple packs as far as frequency sharing, but the packs cannot be on at the same time. Otherwise, you'll get interference because it's a one-to-one thing. One transmitter, one receiver. So if you accidentally leave both transmitters on, you're going to get all kinds of interference. It's not going to work. But if you're very careful and you make sure you turn off, you can't just mute it. So audio muting a pack will leave it transmitting, and you're going to get interference. Make sure you physically turn the pack off, then turn the other pack on, and then you can make this work with one receiver as pictured. I mentioned this is a picture of our GLX-D guitar pedal receiver that can likely accept 1 or 2 packs linked to it in that special way. Here's an example of a couple ULX-D quads. So again, if you're building out more of a guitar rack for a mid to high level tour, this is something where you can do this. If you want guitars to be simultaneously on, then you need multi-channel receivers like this, and you need to coordinate those frequencies if they have to be on at the same time. Again, so that's something that tours will do a lot of the time, is they don't want to be bothered with turning packs on, turning packs off. There's the risk of timing that improperly and then hearing some noise in the system and things like that. So they generally will go with a multi-channel rack system like this and coordinated frequencies. Now within that, you have to manage that still on the back end, right? So I just have a single line going down. The way to achieve that to the amp is through either an audio summing feature that some multi-channel receivers have, like the ULX-D quad receiver and dual receivers have this audio summing. That's fine for one rack receiver. If you have multiple rack receivers like that, you'll still need to mix downwind to provide one signal back to your amp. But more common is what's pictured here, which is a guitar switcher. And there's a lot of third-party guitar switchers out there. Some people build their own. And that's one way that people manage this, to switch through quietly and get the one signal from the appropriate receiver to the pedal board or amp. But just the big warning here is that if you want multiple packs on at the same time, they need to be discrete frequencies and coordinated. If you're But you can do the single frequency sharing thing. Just be very careful about which is turned off and turned on at the same time. You can't do that. So some secondary considerations, and by secondary, I don't mean unimportant. I just mean they're not maybe the primary things to think about. Again, operating range, and we talked about why that's maybe a secondary consideration, but on a macro scale, and I alluded to this earlier, if you're looking for longer range operation, or especially longer range in maybe an arena or mid-sized place, UHF wireless is probably a system that works in that range is probably a better choice than a higher frequency thing. But if you're generally close to your pedal board or in a small to mid-sized club, 2.4 gigahertz may be just fine. Metal receivers and transmitters, again, durability, they're probably more durable, but there's a lot of plastic systems out there where the plastic is a hardened, durable plastic that is quality tested and probably just fine. So metal, maybe okay. It's certainly a good choice, but doesn't have to be the case. Do you need the receiver to be networkable? Do you need to remote view any features about it or change the frequency? That would be a consideration, maybe. But if not, then don't worry about it. But that would certainly dictate which wireless system you get if you need that. Digital versus analog. A lot of times that's an audio quality choice, but we'll discuss which might be better than the other. Rechargeable batteries are another feature that a lot of systems are going to as far as an option or required operation, and that's the technology is getting better, and that's a good thing. If that's something that you want, it's certainly going to steer you in a certain direction as far as which system to get. And then, does the system need to be in a rack? Do you need to mount the antennas in different places? These are all important to consider because some systems allow you to rack mount the system easily and remove the antennas, and others don't. And so all these things combined are going to lead you towards a good choice of which wireless system to get. So the digital versus analog discussion, which is better? It does depend. Certainly, I think it's safe to say that the audio quality in most cases is better with a digital wireless system. It's certainly more transparent, flatter response, wider range, better transient. So pick attacks, things like that, slap bass. If you pluck things hard with your fingers, I know I play a Telecaster sometimes without a pick and dig in the back pickup, and digital wireless ends up sounding great. But in some cases, it might be too aggressive. The analog system offers some companding and compression, which may maybe warm the signal up a bit or tame that a bit. It depends on what you want with that. Some people use compressors in their signal path already, and then they may just want digital because it's more accurate and better transient response out of the gate. So that's a choice for you, but certainly as a apples to apples comparison without anything else, just it's a wider frequency response and better dynamic range. You may get increased battery life on some systems, uh, but digital does have some latency, some digital delay, which is generally not an issue. Some of them are low enough where it's not a problem, but if you're using in-ear monitors or you have other digital stuff in the signal path, that could be an issue. And then the potentially higher channel count for analog systems, that's mainly an entry-level thing or lower end of the spectrum. There are some digital wireless systems that offer extremely high channel counts. They tend to be more expensive. But on the sort of mid to lower level, the analog systems will probably offer a higher channel count option if that's what you're looking to outfit a larger group with wireless. So the latency discussion a little bit deeper. Again, here's some numbers. So again, if a system has 0 to 3 milliseconds, it's probably not going to be noticeable. 3 to 5 maybe noticeable, but probably not a big deal. If you're in that 5 to 10 milliseconds of range, in-ear monitors can sometimes affect what you're hearing and be a little bit irritating. Much more than 10 milliseconds, and you're talking about some problems. So again, a digital wireless system by itself, I'll use our ULX-D as an example. That's about 2.93 milliseconds of latency. Not a problem by itself, but if you have some digital effects, other things in the path that are going to add cumulative latency, then this could be the thing that pushes you over the edge. You may want to think about an analog system. But that's up to you and what you have going on. On to rechargeability. These are some older battery chemistries. Nickel metal hydride is still out there, more common than nickel cadmium. But with these, you kind of have to worry about things like memory effect, battery conditioning, steeper discharge rates, things like that. And the metering on batteries like this was not as accurate. So a lot of systems have gone to lithium-ion rechargeable, us included. Our GLX-D system, in fact, only runs on a lithium-ion primary, and ULXD and some other Shure wireless has a lithium-ion option that you can swap in lieu of the AA batteries, which will actually give you more accurate metering. You don't get bars, you get hours and minutes, accurate to within 15 minutes. A lot of these batteries will keep track of their cycle count, charge status, and give you a lot of information that you can use to decide when to retire a battery. And there's a quick charge profile, usually, even if you've forgotten to charge batteries. The GLX-D, for instance, 15 minutes of charge will get you through the average set. Some of the other ones, charge up to 50% of their life in an hour, and then fully on at 3. So it's really nice charge cycle. There's no memory effect to be worrying about, longer runtime than the alkaline, and a lot of convenient charging options, whether it's a car charger, wall charger, rack mount charger, all kinds of stuff like that. So there's a lot of reasons, compelling reasons now to go with rechargeables because of this improved lithium-ion rechargeable technology. And not all systems have this, so again, that's one of those things where if you're interested in this feature, look for it, whether it's something that you can purchase later or whether it's something that is required by operation of the system. Receiver form factors, again, what are you trying to do? Can the receiver live on top of the amp or on the side of the pedal board? A tabletop fixed antenna design may be just fine. If it's something that needs to live on a rack or you need to be able to move the antennas around, a rack mount receiver, typically those have removable antennas, that's a good choice. If you have room on your pedal board, that's a good choice, maybe over the tabletop type if you're going to live there because it can fit on the board. And some of these systems, our GLX-D 1.6 guitar pedal receiver included, has a built-in tuner, so it can actually save some pedal board real estate by taking the place of both your receiver and your tuner. And that powers off the 9-volt DC board supplies that are typically found there too. So pretty convenient depending on what you're doing. So on to antenna selection and use. So there's different antenna types, and quarter wave antennas, which are sometimes the ones that are attached to the receiver or they come with. They're the shorties in the UHF range. These are typically about, 3 inches, 4 inches or so long. These need to be attached to the receiver. Even if you can remote them, they're not meant to be remoted and mounted on stands. That drastically reduces their reception capability. So if you buy a rack mount receiver and it comes with these short antennas, keep them as a spare to go onto the receiver, but you'll want to purchase some half wave antennas to be able to remote mount. And those are typically about 8 inches to 12 inches long, depending, maybe 8 to 10 inches, something like that, depending on frequency range. And those are you can remote mount those. Those are appropriate for that. If you're looking for longer range operation, directional antennas like paddles that you've seen kind of off the side of the stage, those can be appropriate. They can also be good for increased range in harsh RF environments, even at closer range. We have a newer one that I believe is pictured there called the UA874 that actually has a -6 dB position, which is great for off the side of the stage, giving you the same forward sensitivity of a half-wave antenna, so you don't overload things, but the directionality of the paddle. Because a lot of times people will get into trouble with the older paddles off the side of the stage. It's kind of close, a little too close for comfort, and you end up having some issues from too much forward gain. So this -6 dB position on that UA874 is a great choice. As far as the paddles go, a lot of people will ask, when do you recommend getting into a paddle? What range? until people really get into that sort of maybe 75 to 100 feet away, that might be where you would go with a paddle. Even then, I would probably choose like a 0 dB setting or a -6 dB setting. But that's the minimum. If you're talking 40, 50 feet, that's probably overkill. Again, unless you have an amp that has this -6 dB pad. And the general forward pickup pattern is about 120 degrees, so it's still pretty wide. You don't necessarily have to aim it right at the person, but as long as they're within that acceptance window, you're generally okay. And the reason it's important not to use too much gain is here, visual. You can see that the white scan was done with the appropriate amount of gain, maybe at, I think at the probably the -6 setting or 0. With too much gain involved, and we bumped up the amp on that paddle, you can see, not only can you see extra TV stations, those big green square wave looking things, uh, but you can see ones that didn't even show up in the other scan, and there's additional noise. So this is why too much gain can make matters worse. So for receiver placement, if you're doing pedal boards, be careful. A lot of those pedal boards, especially the pedal trains and things like that, are metal, and as soon as you lay pedals on top, that's a whole lot of metal on top of these receivers. If you try to tuck them underneath, I've talked to a lot of people that try to zip tie these single channel receivers with fixed antennas under the pedal board, so they're not laying off to the side, or they don't have the antennas properly arranged there. That's really not a great place. It may work if you're standing right over the pedal board, but if you try to move around the stage or step into the crowd, metal does a really good job of reflecting RF. So it's likely that your signals most of your signals getting kind of bounce off the pedals and the pedal board away from your receiver. So the best place to put it really is off to the side, even though it may not look great, or up, you know, in front, but not underneath. Extend the antennas properly. Or if you have room on the pedal board, mount it there. You can do that, but make sure the antennas are up and extended properly. Of course, pedal-shaped receivers are probably the easiest to integrate. That's one of the reasons they're popular design. Just be wary, again, that if you have a stage that's floor level, uh, people are going to attenuate your signal. So that's something to be conscious of. If you have a floor level thing, or you're going to have to go where people are going to block your signal path, this is where having a receiver where you can take the antennas off and get them up in the air is a really good thing. And you can see there, some are like 6 feet in the air. Uh, that's really going to do a great job of improving your range. You want to space them at least 3 inches to 12 inches away, and this goes into our discussion about diversity way at the beginning. At least a quarter wavelength is appropriate. So 3 to 4 inches is going to give you sort of the minimum diversity benefit. 12 to 19 inches apart is going to kind of maximize your diversity performance. So at least that distance away, that gives you the best, link, as far as antenna A versus antenna B. And orienting the antennas at about 45 degrees is good, because that's also going to assist with reception, because as the signal bounces around the space, and as you move around, you don't know what the orientation of the incoming wave is. And this helps kind of minimize any reduction in signal due to the wave being sort of out of polarity with the antenna. But that's kind of the origin of that rabbit ears arrangement. It's a good idea as far as best practices go. Further discussion on adequate spacing. So here's a shot taken on a tour, side of a stage. And this is actually extreme spacing. And it's okay to space the antennas even further if you want. This is going to give you better coverage, and can also assist with using certain types of diversity in larger venues. Some diversity is called switching diversity, and this is where it's either antenna A or antenna B, and others can kind of look ahead and compare the audio quality of antenna A and antenna B. We call that MARCAD. Some other people call it true diversity. With switching diversity types, sometimes this further spacing apart can actually assist improve that performance. That's one of the reasons for that type of spacing. Just be mindful, with spacing like that, it's likely that you're using longer antenna cable to get back to your rack. Antenna cable has has signal loss within it, and it's different depending on the cable. So just be careful. If you use longer antenna cable runs, try to avoid cable types like RG58 or 59. Those tend to be higher loss Um, like so, you want to use better cable, lower loss cable to get back to your rack. Otherwise, the signal by the time it gets back to your receiver rack will be too weak for the receiver to do much with it. So antenna distribution, how to do multi-channel guitar racks. If it's just a 2-channel thing, you can do a passive splitter. You get 3 dB of loss. We have a part called the UA221 passive T-split. It's fine for 2, but if you're doing a rack of more than 2, active antenna distribution is the way to go. Here's a picture of one of those boxes at the top. It's called the UA844. We have a couple others. But this is where you get your 2 antennas that you can move around the stage conveniently rather than 4 pairs of antennas. And then the signal gets distributed down to the different receivers. And that's really the sort of best practices, most elegant way to do guitar rack type things. The antenna farm is not a good idea because having antennas really close to each other can disrupt their reception polar pattern and make your range not as good. Conveniently, some guitar systems or some wireless systems have RF cascading. So here pictured is our ULX-D quad receiver. So there I'm doing 8 channels of guitar wireless with 2 antennas without an antenna distribution box. Um, some systems allow you to cascade more. It all depends on how many channels you can cascade depends on the system specifications, and that's important to know. So something like our UHFR wireless system can do up to 10 chassis or up to 20 channels cascaded. The ULX-D can do up to 2 quads, so up to 8 channels, and other systems are different. But you have to cascade to the same frequency band generally. You can't cascade to different ones. And if you lose power mid-rack, the one warning we have is that you'll also lose reception and networking and everything below. Even if the other receivers are powered on, you'll lose the signal there. But it's a convenient thing to be able to do. If you're going hog wild and you're on a big tour and you've got tons of the big guitar rack, this is the appropriate thing to do. You've got a master distro and some second level distros that have the receivers connected to them. But just be aware that going a third level in terms of active distribution is not recommended. So here's some resources for you. And again, we are recording this webinar, and you'll be able to go back and look at this and copy these websites down if you want for later. And with that, we should open up to questions. I know we're right about at the end, but we probably have some time for a few things.
Okay, we do have a couple of questions, a couple of very application-specific questions. What would you recommend, Dave, for a guitar player who has multiple guitars, and he wants to use wireless? What would you recommend maybe having a different pack for each guitar, or because those guitars are going to have different input levels, So what's your recommendation for that sort of setup?
Right. Well, what we end up seeing in a lot of setups is just that, where people will have a transmitter dedicated for each guitar that's set for the appropriate gain structure. Because to your point, some are active, some are not. They all have really different degrees of outputs. So that's usually what we'll see. On the back end, on the receiver side of things, how people deal with that varies. So I brought up that picture before where there was the switcher, where there were discrete channels, and they went through, and there's a lot of third-party switchers, or people will have them made, so we're not going to go into that. There's actually a neat thing some people have found out with the ULX-D quads or systems that have audio summing, is that you can turn on this audio summing feature, and it'll sum the 4 channels down to 1 output. So you can feed that 1 output of the receiver to your amp. The 4 guitars have their packs on them. You just have to be, and it's fine. All the inputs are summed to that 1 output. You just have to be careful that you mute the other guitars that are not in use. But it's sort of like, yeah, you're discreetly putting transmitters on the guitars themselves, but you're sort of sharing the amp in a lot of ways. That's another way of doing it instead of a switcher. Just depends on your comfort level. But yeah, so you're going to have to, and then of course coordinate frequencies and do all the things we talked about. But I think that's generally cleaner. It sort of depends on your time frame and setup and budget. I mean, if it's a low budget operation and you have the time to quickly switch from one guitar to the next, you can do that. It's just usually it ends up delaying things and looking kind of messy. So that sort of depends on your show, but it is certainly cleaner and quicker to have discrete, transmitters on each guitar and just kind of grab it that way.
Okay. So we have a person here that's using one of our recently discontinued models, the PGX-14, and the player is hearing clipping or muting the volume and dynamics of the sound. Should he or she be editing the gain structure using the dip switches on the transmitter?
It sounds like it. That's probably, yeah. That system has 3-position gain switch, so likely the guitar it's either active or just a slightly hotter pickup. You could probably try putting it on the lowest setting and seeing if that helps with the issue. Um, those uh, those systems too. There's a certain range where you get into in the dynamics where you might hear a little bit of a nonlinearity as far as the gain, like the companding, because it's an analog system. It does have companding. It's a variable companding scheme, so it's a little better than some even older stuff, but it's still, you know, depending on where you're at in that range, you could hear that sort of pumping or quick decay of the sound. But this clipping distortion thing sounds like I would check the transmitter first and get that gain down.
Great. Okay, another question here, and this is one actually I can answer. The person has a PGX system that they're using with a lavalier mic and asking about if that can be used for an instrument. Most certainly, the body pack transmitters are the same whether you're using a lavalier microphone, a headset microphone, or an instrument. All you have to do is get the instrument cable that we make that goes from that TA4F connection to the input for your guitar. So, yes, it is totally versatile in that way. Another question here, which I think you kind of touched on, but just to reiterate, is a directional antenna needed if the receiver is 50 to 60 feet from stage?
Uh, Probably not. Um, Again, it's somewhat depends, but 50 or 60 feet should be well within the range of a typical passive half wave. Um, as I mentioned before, though, some people like the comfort of knowing that they're kind of focused on the stage, in which case that's why we have this new -6 dB setting on it's called the UA874 directional antenna. At that range, I would probably most definitely use that -6 setting, and that, as I mentioned before, gives you about approximately the forward sensitivity of your typical half wave passive omnidirectional antenna, but with the directionality of the paddle, which can assist if you know kind of approximately where TV is transmitting from. You aim away from that directionality can kind of help you. But in general, no. I think the biggest things that'll help you with range in that scenario is get the antennas up off, away from the ground, away from the rack, up in the air, and good clean line of sight to your transmitters, and that should be more than sufficient.
Okay. What is the typical input impedance of Shure's transmitters?
Well, there isn't really a typical. I think if I remember, some systems are a meg. I think one is it, well, Axient, I think, is a meg where it's switching. ULX-D might be similar. It's going to vary by system. I don't think there's a typical one. I know that certain systems, because of the way the input was designed, probably do a little better with this. I think newer ones we've paid a little bit closer attention or getting that. Like ULX-D, I know was specifically designed to work with that. I think the pad setting actually, particularly for instruments, so I think that affects something to do with the input means, if I remember correctly. Axient, which is crazy expensive, but still has had some things designed for that. Uh, yeah, it kind of varies. I don't think there's a typical one.
All right. Well, I think that just about wraps up the questions here. So if you have any other questions that come up, please feel free to send an email to support@shure.com, or you can also always call our engineers here, and they'd be more than happy to answer any questions you've got. We want to thank you so much for joining us, and we will see you next time.